Fortunately, we can do this, and it's because of the flexibility of the for loop. And I pointed that out to you a little bit earlier, and I said we'd come back to talk about how the for loop was more flexible. Let's see an example of this. So the for loop is not just used to count from one number up to another. We can also use it to iterate over the elements of a dictionary. So instead of saying for x in range 500, which is going to do something 500 times, I can say for pi in pizzas. That's pretty cool, right? So what it's going to do there is it's going to use pi basically becomes every single key. So cheese, bacon, vegetable, pepperoni, whatever else I had in there. That's how we iterate over all of those keys in Python without having the value of integers that we did previously. So for example, here's the original pizzas dictionary that we had just a moment ago. If I say for pi in pizzas, print pi, because again, pi is substituting for the keys, this is going to print out for me a list of all of the keys in my dictionary. So these are maybe the kinds of pizzas that I have available. Or for pi comma price in pizzas.items. Now I have to specify pizzas.items here to make it so that it can iterate over all of the keys. Excuse me, over all of the values. I can iterate over all of the keys automatically in a dictionary. But if I want to iterate over the values, I have to transform the dictionary into a list. And in order to do that, I need to use the .items method to transform my dictionary into a list for purposes of just iterating over this. Then I can print out the price. So in this case, I would print out 12, 10, 9, 11. That's weird. It didn't print them out in the order I specified, and that's kind of the side effect here with the dictionary. You're not necessarily going to get your, when you transform the dictionary into a list to iterate over it as we do here, you're not guaranteed that that list is going to maintain its order. Now the key keys and values will still be associated correctly if I wanted to print out both, as we'll see in just a second. But the order is not guaranteed anymore. Now, usually that's not going to be a problem. Sometimes it might be, in which case you're just going to have to use a list at the outset. And there are, of course, ways around it. Let's say I wanted to print both the key and the value. It's very similar to what I just had before. I'm still iterating over pi and price, and I'm still transforming the pizzas dictionary into a list temporarily so I can iterate over it. And I'm using my print function again here now I'm not specifying 0 and 1. I could and specify 0 in the first one, 1 in the second one. But I want to actually print the key first, then the value. I don't want to have to invert them, so I don't have to plug in the ordering that I did before when I was doing the president's example, iterating over all those tuples. And this would print out A whole buffalo chicken pizza costs $12. A whole cheese pizza costs $9. Again, going through each element and getting the key value pair and printing it out as I indicated. So that's how I can iterate over an entire dictionary, printing out all of its elements, again with the caveat that it's not ordered, so I'm not guaranteed to get them in exactly the same order I put them in. But again, that trade-off is probably going to be worth it most of the time. So now we've seen a lot of examples of this, how to interpolate variables similar to printf, where we would use percent substitution. In Python, we've seen this one quite a few times. There's also this one, which would allow us to concatenate strings together. So here I'm not doing any interpolation, but I'm plugging in the variable pi and the variable price, transforming it into a string, because everything else here is a string, so I need to transform that number into a string to make this work correctly. So that's what the str function there does. But this again would work, so a whole cheese pizza costs $9 turned into a string. You might see this, which is actually really similar to using printf, but it's deprecated in Python 3, so you don't really want to use it, even though it might be more familiar to you because it's similar to printf. So you might see it, but try and avoid using it because it is deprecated. So again, Python is not just a main function that we just run down all the lines. In fact, Python doesn't have a main function by default. We have to kind of explicitly force it to have a main function if we want to. But it does support functions more generally. And we don't need to specify the return type of functions, and we don't need to specify the data types of any parameters. So recall from C that we had to specify like int square, maybe it took an integer as its input, so int square, parentheses, int x, semicolon, or all this stuff we have going on. We don't have to specify any of those data types. We just have to specify the name of the function and any parameters that it takes. We introduce a function using the keyword def. So basically think about it as like defining the following function. And because the interpreter reads from top to bottom, we don't have to include our main function, but if we want to include main because maybe we wrote our code such that the stuff we want to execute first actually is maybe 200 lines into our file, we wrote other stuff up above, maybe we're keeping our functions in alphabetical order or whatever else, we can explicitly direct our program to start at the main function by including this line at the very, very end of our Python file. And this is just something to memorize. If underscore underscore name underscore underscore equals quote underscore underscore main underscore underscore quote colon and then tab in main parentheses. This is one of those things that you don't necessarily have to use because if you write your code such that the first line is the first thing you want to happen, it's going to be fine anyway. But if you write it out of order, this is just one of those things you just have to memorize. Sorry. So defining a function, pretty straightforward. Let's do parentheses. This is one of those quote, colon, and then tab in main. Main parentheses. This is one of those things that you don't necessarily have to use because if you write your code such that the first line is the first thing you want to happen, it's going to be fine anyway. But if you write it out of order, this is just one of those things you just have to memorize. Sorry. So defining a function, pretty straightforward. Let's define the square of x, like we just did a second ago in C. Def square parentheses x colon return x times x. Pretty straightforward. I could also do this. I could return x times 2. Well, actually, this operator here is a built-in, which C did not have, exponentiation operator. So this is return x squared. I can also be really convoluted and write my square function by adding x to itself x times. It doesn't really matter. As long as the result is the same, it can be a black box, just like we talked about in our function video. We don't necessarily care how the square function is defined, as long as it does what we expect it to do, as long as printing the square of 5 prints out 25. All right, now here's something entirely different. Let's talk about objects. So objects we have not covered yet in CS50, and Python is an object-oriented programming language. The closest thing we have to an object is a C structure. So C structures, you may recall, have a number of fields in them. We might call those fields, particularly in an object-oriented context, properties. Well, those properties are never kind of able to just be on their own, right? They're always bound up and tied into some definition of some C structure. So if I define in C here, as I do at the top right, a car structure that has two fields or two properties in it, year and model, I might be able to say the following. Struct car Herbie, I'm declaring a new variable of type struct car called Herbie, and I'm saying Herbie.year equals 1963, Herbie.model equals Beetle. Totally okay, right? Because in each case where I'm using year and model, I'm associating it with some structure of that data type, in this case, Herbie. But I could never say this. This is not valid in C, at least with what we have here, because year and model don't just kind of hang out on their own. They're attached to they're part of what it means to be a struct car. So we always have to associate them with a struct car. So that would not fly. So that's sort of the analogy of object properties to C structure fields. But objects, in addition to having properties, also have methods. You've heard me use that word a couple of times so far in this video. Methods are basically functions that are inherent to what it means to be an object. You can't call that function just kind of out of the blue on anything. You can only call that function on objects of that type, on objects where that function means something. So properties and methods don't ever stand on their own. They're always part of what it means to be an object. And because of this, like, objects become a lot more important. Always part. In all or many of the properties of that object with some data. Then, in addition to defining the properties of the object, we also have to define functions or methods that can apply to the object. Every method that we define inside of the class has at least one parameter, and that parameter is canonically, although you don't have to call it this, is called self, and basically all it is a reference to the object, so that we can always know what object we are talking about. So every function that you write, every method that you write in a class to define some new kind of object will always have one more parameter than you think you need, because the first parameter there will always be self. Let's try and distill this into some actual code so you can see what we're doing here. We're talking about defining a new kind of class, defining some methods, and then we'll see how we can apply those methods to objects in that class. So here's a very simple class called student. So class student with a capital S, apparently this means that I am now going to create, whenever I want to create a new student object, I'll use that capital S student keyword. And I'm defining three functions. The first is that constructor, that initialization function, which is always called underscore underscore init underscore underscore. Now my student apparently is going to have two properties. They're going to have a name and an ID, but because I'm defining a method inside of that class, I always have to include that self parameter so that I always know what object I am talking about, or what object is being invoked here. Inside of my initialization function, I'm doing something pretty straightforward. I'm just saying self.name equals name and self.id equals ID. So I'm assigning the name and ID properties of the student object to be whatever I pass in here. And then I have another function called change ID, and apparently I use this and to change the ID of a student, the ID number of a student, after I've already created them. Because I'm assigning the ID when I initialize it, but here apparently I've already created the student object and I'm going to change it. So change ID takes two parameters, self, again, so I know which student, which capital S student object I'm talking about, and the ID number that I want to change them to. And then I have a function called print, which takes just one parameter, self. It's apparently not going to take anything else, but still I always have to indicate the self parameter always has to be part of any method that you define for a class that you create. And apparently what I'm doing here is printing out self.name and self.id with a little dash between them. That's what's happening there. It's just some variable interpolation, just like we saw before. I'm just printing out self.name dash self.id. So what would happen here? So I'm creating a new variable, a new object called Jane, and this is my initialization. I'm calling the constructor function. Jane equals student with a capital S, again that's the name of our class, and I'm passing in two values, Jane, which I apparently want to map to self.name, and 10. So immediately after this, what would happen is I would have a new student object called Jane, and Jane's name field would be Jane in quotes, and Jane's ID field would be 10. So if I printed it out, and you can actually take this code and recreate it in CS50 IDE and see it for yourself. If I then printed it out, I would print out Jane space dash space 10. Then if I executed Jane.changeID 11, you'll probably guess what would happen. So when I then printed again, it would print Jane space dash space 11. So that's just some examples of defining a class, defining methods, assigning properties. Again, all of this sort of is inherent to what it means in an object to be working in an object-oriented programming language. So even though this may be very unfamiliar and new, especially coming from a language like C, this, if you go forward and do object-oriented programming in languages like Python, like PHP, like JavaScript, like many, many others, this sort of notion of methods, properties, and how we work with them is going to be really important to sort of synthesize. So if you haven't noticed by now, good style is really, really important in Python. We don't have curly braces anymore, which is great, but we still need to be able to then indicate like how an if block is delimited. In C, we had an open curly brace, and then we had some code, we had some closed curly brace, and it didn't really matter how things were styled in between. I mean, it mattered for somebody who's reading your code, but it doesn't matter to the computer. It does matter in Python. Tabs and indentation are key in order to indicate what you intend for it to do. So if I had an if block and I put a colon at the end of it, and I didn't indent the next line in, Python wouldn't know that that line is supposed to be subject to that if condition. So if you have not yet been in the habit of practicing good coding style, now is the time to definitely reacquaint yourself with the CS50 style guide, because if your code in Python is poorly styled, it's probably not going to work. Sorry about that. So in C, we had the notion of including files. We needed to get additional information from libraries, for example, like standard.io or cs50.h. We can do the same thing in Python, and C it was pound include. In Python, we import, and instead of being called header files or libraries, we generally call them modules. We could import CS50, and if we do, we could then call some of the CS50 functions we might be familiar with. We can do that by saying, for example, CS50.getInt, parentheses, and that would, just like getInt does in C, get an integer from the user. CS50.getFloat, .getString, .getChar. All those things that you've used in C, we can still use them in Python. They just take a little longer to type. We have to specify CS50 dot, because CS50 is basically, not exactly, but it's basically a class where we're defining a couple of different methods within it that we can then invoke. You can, in addition to pre-writing your files in .py files, you can also just literally write Python using the Python interpreter at the command line. You can type in your IDE or in a lot of environments Python and then hit enter, and it will open a Python interpreter, and you can literally write Python one line at a time. In general, though, if you're going to be writing more complex programs, you're going to want to pre-write them and then load them into the Python interpreter instead. To invoke the Python interpreter, particularly in CS50 IDE, but again more generally, Python space whatever the file you want to invoke is, and then what will happen is the interpreter will open that file and receive one line at a time, top to bottom, executing your Python code. And if you really want to make your Python programs look and run a lot more like C programs, for example, in C, once we compile a program into, say we make hello, we then have /hello, we can include this line in red at the very top of our Python file, and then we can execute the line in blue after we're done saving the file, and then we can actually, instead of typing Python and then some whatever we want to call it .py, we could then just write /blah blah .py. So again, I know that was a long video, there was a lot to cover in that one, and we've really only just scratched the surface of introducing you to Python, but it is an amazing language, incredibly flexible, and it's a tool you're really going to want to put in your programmer's toolbox if you're ever doing anything like data science or complex string manipulation, or really just familiarizing yourself with a language that you can use both at the command line and in a web development context. And we'll talk about how we can use Python in a web development context in another video on Flask. I'm Doug Lloyd. This is CS50.
and wants sustainably.
Alright, today we are going to be looking at the difference between list, tuple, type, and dictionary in Python. So, I'd like to remind you to subscribe to my channel by clicking on the subscribe. So if I go ahead to run this, right click and then run selections, it's going to walk through our process. Alright, let me Alright, so you can also go ahead to say frames. So we are going to create them and then mention the differences between them. So I created the first one. This is a list, and this list is comma separated items enclosed in square braces. So the keyword we need to take away from there is square braces. So that is one thing you need to know about the list is enclosed in square braces. Let's focus on the differences and later we'll talk about the similarities. So when you are creating a list, you can even put any other item inside of the different data types. So it's going to work. So if I go ahead to run this, right click and then run selections, it's going to work through our process space. Alright, let me Alright, so you can also go ahead to say frames list one. So if I print this one, you can see that it brings it out to the output. You can see it brings out everything. So let's look at the other item, and that will be tuple. Let's look at tuple. Tuple is also a list of items separated by comma. So let's create a tuple of tuple one. In fact, let's just copy this list and then make the changes that is going to make it into a tuple. So let's just call it tuple one. So at this point, why can we say this is a tuple? Of course, this is still a list, even if we give its name tuple one. A tuple is enclosed in rounded braces, right? And enclosed in rounded braces. So if we enclose the list of items in rounded braces, the compiler understands that we are creating a tuple. So let me just enter it here. The keyword is rounded braces. So this is a tuple and this is a list. And the same operation print tuple one is also going to print exactly the same thing. So let's go ahead to run it and see. So if you look at the output, you see that there's actually no difference. But I'm now telling you that one key difference is that a tuple is enclosed in rounded braces while a list is enclosed in square braces. Another difference you need to know is that a tuple is, you can see that in the output, the first item now is a PC of a computer, so it actually works. Let's try to do the same thing in a tuple and see if it's going to work. So let's say tuple 1, tuple 0 I mean, is equal to PC. So this actually is not going to work. I'm going to write it out. Not going to work in a list and tuple how. So we are going to solve. I'm going to use the set keyword. Let's see. Okay, that is correct. So let's take out this confusing you. So it expects to have. So it's more like we are given a single list points in there. So it's going to print. So I'm going to print this space, and you see that there's not much difference between these and the polygraph. Yeah, because our work will be less function. I think if I run here, print. So meaning that you cannot change the first the key in the first hyphen in the dictionary.
And this was a subtle thing we introduced me to, where you can actually hear my and going to that specific name within there, using F string for the whole thing. So this is similar to search before. Linear search and dictionary lookups will just happen automatically for you in Python by just asking the question, if name and people. And this line just going to print. So whoever is in the people dictionary at that name. So I'm using square brackets because here's the interesting thing in Python. Just like you can index into an array or a list in Python using numbers, 0, 1, 2, you can very conveniently index into a dictionary in Python using square brackets as well.